So we're going to pick up where we left off, which is with data preparation, and we're going to talk today about pre-processing. So we talked about, well actually on Friday we did Weka, but prior to that we were talking about the sources of the data, and here we're going to actually start processing our data. And it's basically a multi-step process, because the data is what everything hinges upon. If you don't have good data, then you can't guarantee good results. So the first thing we want to do is, when we look at our data, is to clean data. And we'll talk about exactly what that means. That means if we have inconsistent values, and those sorts of things, what are we going to do? There's different processes depending upon the data that we have and the algorithm. On Monday, we talked about that.
Monday?
And
Wednesday.
Monday,
Oh, yeah.
downstairs.
Come on, Nicholas.
And so if the algorithm's if we have continuous data, but our algorithm is going to want discrete data, there's going to be different ways of discretizing the data to put it into. So we'll talk about several different ways of doing that. Then we're going to talk about data integration, or sometimes also called aggregation. This is a way sometimes we want to smooth our data to take care of rapid fluctuations that really aren't of interest, or we may not want to smooth the data. So a lot depends. In the smoothing process, you get rid of some information, but you might be able to see things that you otherwise would not see. So that's the process there. And again, a lot of these, and we'll talk about this at the very end as well, with data mining, ultimately, everything comes down to the problem at hand. So if we have huge amounts of data, sometimes there's extraneous information, and if we have too much information, unless you're like Nick here and has access to NSA computers, it's hard to process all of that data, right? So we might be interested in reducing data to a manageable level. And it's going to be faster and so forth. And so again, we've got a number of different techniques here. We can use sampling methods. We don't use all the data. We can use dimensionality reduction. We can, and one sort of dimensionality reduction is feature subset selection. An alternate way, which I'll talk about, I'm going to talk about each of these topics in a little more depth as we go through today, is actually creating new features. And you think, well, that's going to actually add to the complexity. But if you're smart in how you do that, it can reduce your dimensionality. Then, again, depending on the process at hand, or the problem at hand, you might want to transform your data. You might want to change your variables. So examples of that are scaling to be within certain ranges, or you might just be interested in sorting your data from best to worst, 1 to 10, so on. Questions so far? So I'm kind of giving a big picture, then we're going to dive down into more depth as we go forward. And then some other things you can do with your original data is some mathematical computational techniques. Normalization. So normalized data that could be based on a Gaussian curve, or you can do other sorts of normalization. Stationarity. First of all, what does that mean? That means that's more particular, as we'll come across here. That's really more related to more time series data, where the source of your data maybe the mean might be, or standard deviation might be changing, and so how are you gonna handle that? And then there's a whole bunch of statistical, computational methods we can apply to the data. Maybe you've got so much data, and in essence, again, some of this can reduce the complexity. If you've got whole bunches of sensors, maybe you just want to average groups of sensors rather than using all of your data. You're going to lose some information, but again, if you're going to try to do a whole bunch of computations using these algorithms that will develop once we're done with the data section, that's going to make things easier. Or another thing you could do is maybe you have, again, data every second. And what that means is if you're trying to measure inputs, is almost none of those inputs occur, and almost all of those inputs are zero. So maybe you really want to aggregate that data over a longer time period and start looking maybe at how many events per day or per week. And again, all of this depends on the problem and the data that you have. And so it's really important there. Other statistical computations that we can do, obviously median mode, any basic sort of statistical computation, standard deviation. We can have weighted means if we think that that's going to be useful. So now we're going to actually dive down into each of those kind of big, broad topics. First one is cleansing the data. So preparing the data, making sure that it's valid to begin with. So what sorts of problems could we have? Well, we've talked about it a little bit already, but our data might be missing. Okay, what are we going to do? We might have improper data. You get Eric's weight and it ends up being 5 pounds.
That's pretty accurate. How much helium you hold on?
So there's a problem. In other words, in the data collection process, things can go wrong. And so questions are, how are we going to detect errors in data? Especially if you've got massive amounts of data. I don't think you're going to go through by hand to find all those errors, right? And then another question, how or do we want to handle noise, statistical fluctuations that may or may not impact our results? So again, and some questions to ask as we start going through these process. So suppose we're looking at missing values. Why are they missing? Is it because Cody was lazy that day?
Probably,
and just forgot to ask certain questions? Yeah, or alternatively, maybe there's a reason for those missing data points. Maybe they actually are meaningful, right? So it's possible that there's some meaning attached to the fact that there were missing data points. And same question, similar questions about handling inaccurate values. First thing is, how are we going to identify those inaccurate values without going through all of the data necessarily by hand and saying that makes no sense? So can we use some exploration techniques of the data to find outlying points and maybe then just investigate those points? Common errors. I mean, these are common in your book's ISBN. You type in the wrong ISBN number when you're ordering your book, the computer almost instantly will say that's not a valid ISBN number. Anybody encounter that? Have you done that? Why?
Because I typed it in wrong.
Probably one error is a transposition error, right? 2-3 becomes 3-2. Do they look up the record that you typed in against a huge database, do you think?
Yeah. No, I'm sure they've got some error checking built in.
They've got an error checking algorithm built into the number, and in that case it's a check digit. The last digit is a mathematical function of all the other digits, and if it doesn't match, then it can instantly tell you that it's wrong. But how are you going to find typographic errors in the data that you have? Transposition, missing, whoops, I just skipped a letter, skipped a number. Errors in measurement. Again, how are you going to identify and how do you want to correct those? Duplicate values. Maybe for whatever reason, you have the exact same instance in your data and it appears twice, right? So how do we want to handle that? And again, how do we want to handle noise? A couple more questions to ask. What about irrelevant data? And why are you deeming that data or the system deeming the data irrelevant? Is it actually irrelevant? It might be, it might not be. And what about the age of the data? How old is your data? We discussed that on Monday. A little bit in passing, right? Now, do you want to treat older data with the same, as important as your most recently collected data? Or were your measurement techniques as accurate on your old data? And so these are tough questions to ask because depending upon how you handle each of these problems can impact your results that you end up with. So we're going to continue here with talking now about some possible handling methods for particular issues. There's a missing data point in a particular instance. One possibility is eliminate the entire record, the entire instance. Obviously, if you have missing data points in everything, now you have no data. Maybe it's a different point, but you can eliminate particular data attributes, different features. Eric's weight was way off. Maybe you don't want to include weight. Eric's weight was way off. Maybe you don't want to include Eric.
That's cool. I don't want to be included anyways.
Okay. So here's not including Eric and here's not including weight. So those are two different ways of handling that. You could estimate missing values. that doesn't mean you can, you're not gonna, especially if it's a person who's a little heavier than average, you're not gonna necessarily get the right value. But Eric's obviously not 5 pounds, maybe you wanna average the rest of the class and just put that as his weight. So
Okay.
interpolation from nearby points, if you have sensors, maybe you're missing a rainfall amount at a particular sensor, but you've got 4 other sensors that are fairly close by, so you'll just average those 4 and use that as your missing data point. You can ignore the missing values, see what happens. Or depending on, you can input a 0 there. Again, depending upon the data set and the problem at hand. We talked about this already. How do you identify inconsistent values? And one approach is if in your data collection process, maybe you have a way of applying a check digit at the end as you're collecting the data, so that if it doesn't agree, now you already have a way of detecting the data. But the problem is most data sets aren't collected at the start. We rely a lot on older data sets, and now there's lots of missing data, lots of inconsistent values. So
As well as whether the data is valid or not, right?
whether the data is valid, what do you mean?
Like with the old data, I mean, it could be not as precise.
Not
it
as
should be.
precise, okay. You have older measurement
Right.
tools. So maybe there was a change made in the technology, and now you have much better techniques for measuring. And so again, comes to a lot of these. There's a lot of overlap in what we're going to talk about in terms of data pre-processing today. And in a lot of these techniques, that goes back to the age of the data.
Yeah.
So as we'll come up to there, one possible way of handling that is through weighting. Maybe one possible way is elimination of all data before a certain date. Well, now you've got more limited data, you're not going to see the time trends as much, perhaps. Another possibility is weighting older data less than newer data. As data ages, you can have a mathematical function that automatically discounts earlier data. These are all choices that you get to kind of make as you're going through this process and trying to improve performance of your data mining. So, for duplicate data, we can remove duplicate data. Again though, you have to be a little bit careful. Yeah, James.
Are there instances when you don't want to remove duplicate data?
Well, first of all, are they duplicates? Maybe they're an identical value, right? But they could come from two different, if talking about people, maybe the individual values came from two different people or two different sensors.
A lot
Cody's
of these
Pablo's
instances are kind of based on what you're trying to find the data for, or what the data
Right.
is for, right?
So that's the question here. Are the duplicate instances errors, or are they actually just identical values from two different measurements? Maybe not even the measurements of the same thing. They might be measurements of completely different things, but they just gave the same value, right? In which case, you would definitely want to keep those duplicates because they're really not extraneous. They're the information that you want. You're just getting that value multiple times. Whereas so the difference would be if I get all your information, Cody's doing the sensor, and he gets all of James' information, and then he goes back and gets it again, and includes it twice. That's a duplicate. And that can impact your results. And that's what you don't want. Versus maybe Cody gets James' information, and then Cody goes over to James. To Pablo. But all the information about the Pablo is identical with the information about James.
That's not a duplicate.
That's not.
Then that's not a duplicate. It's just the same information from two different
What information are you trying to
sources.
What is it?
So other things you can do, remove irrelevant data, remove dated data. We talked about that already, the older data or weighted. Other questions at this point? What about questions from Daytona Beach? I don't know if their mic is on. I don't see any questions coming up. So another topic that, in that big list at the beginning, discretization. Right? So what does that mean? That means you've got continuous data and maybe you want it not in all the possible values, but you want to discretize it so it's in a finite or countably infinite number of values. Some methods for doing that. Binning. Okay. So I think the name kind of says what it is, but I want to hear what you think it is. James.
You take the cream of the crop data, you take like the best of the best data that you have and use that for processing.
Jeremiah.
Kind of separate things out into bins, like if you're only worried about certain interval sizes, then it doesn't matter if it's 0.1 or 0.2.
So it's basically, right, if you have values between 0 and 1, so there's different ways of binning. One way would be to get how many values fall between 0 and 0.1, how many between 0.1 and 0.2, how many between 0.2 and 0.3, between 0.3 and 0.4.
So it's organized.
So that would be an equal width interval binning. But other possibilities are, say you have 100 data points, and you're going to look at, in statistics, you're going to look at, say, percentiles or quantiles. Here's the top 10% go in one bin, the next top 10% go in another bin, the next 10% in a third bin, and so on. Two different ways, completely different ways of binning. Equal width versus equal frequency. You can use clustering techniques. You're going to put together bins of things that cluster together, which is more similar to that equal frequency binning, right? And a couple of methods of doing that, which we'll talk about as we get to the algorithms. K-means and some hierarchical methods. Binarization, that's a special case. You want to put it as zeros or ones, trues or falses,
Success or fail.
success or fail. I'm probably not going to talk too much about this, except unless we get to it, but entropy-based discretization methods. And then what do you do if you have multiple variables and you want to discretize those? It's pretty straightforward, but. So now we want to talk about data integration or aggregation, and really this is more about smoothing or averaging your data. So if you look at, I don't know if anybody's ever seen kind of smoothing methods of data with a lot of noise in it, and you kind of take, so in time series of, say, stocks, they'll often talk about the 5-day moving average or the 30-day moving average. So what that means is you're going to look at time windows, say 30 days each. You'll average over those 30 days
You get one.
and you get 1 point. And then you shift your time window to the next day, you get another point by averaging over the next sequence of 30 days.
Okay.
And that just smooths out rapid, kind of more your high frequency fluctuations. So you can see, I mean, if you look at stock markets, if stock prices
Just don't
changing on every single microsecond, and you try to make sense of that, that gets down to all that extraneous data. So this smooths it out, so you're not seeing like these wild fluctuations, but instead you're seeing a smoother sort of curve that you can actually do more with and will take less processing. Sampling, exactly what it says, right? You've got huge amounts of data.
Copious amounts.
Right. And maybe in order to get your computer to finish before the end of the decade,
End of the millennium.
pardon?
Could be the end of the millennium.
End of the millennium, you might want to just take samples. But then you have to, again, all these questions come up. You want representative samples. So a simple case of that is simple random sampling. You can do that with replacement or without replacement. You look confused,
What
James?
do you mean by with or without replacement?
Okay, suppose the 8 of you, it's a small sample, and we want to get 3, right?
To replace Cody.
So one possibility is with replacement is I choose Jeremiah, I choose Cody, but every time I choose someone, they go back in the pool, and now I can choose Jeremiah again.
Why would you do that?
Because I'm off.
By random. It's just random
It's
choice.
like rolling a die, right?
Okay.
Or it's like take,
So you can get the same one multiple times.
You can get the same one multiple
Or you can
times.
remove it.
It's less work. I mean, if you're looking at a big data point or a big data set, it's probably not gonna make a difference, because if you've got 100,000 data points,
And you're bringing to
the
100.
chance I'm gonna pick Jeremiah twice
Pretty slim.
is pretty slim. Right? If they're equally weighted. And with 8, it's gonna be more likely, but
So
James,
you're kind of creating your own database off of older data. So you're kind of,
the age didn't, I don't know where you got the age there, the older data.
No, what he's kind of saying is if you've got too much, you just randomly pick certain data points out and put that into a smaller set of data.
so you're just minimizing the data.
Minimizing the data.
So my question with that is, how do you know how many, or the size of the sample that you want for the population?
Oh, good question. How do we know the size of sample size?
Good question.
Good question, right? So you have to figure out what would be a good sample size. And it's gonna again depend on the problem at hand. So, and then stratified sampling. Anybody know what stratified sampling is? Maybe you've got different groups within your entire, you know that you have different groups within your entire data set. Male and female, older and younger, race, okay? So now you want to try to make sure that you ensure a representative mix across your sample.
You have to take a certain percentage
From each one, exactly. So that would be a stratified sample where you take a certain number of your Anglo-white Protestant and so many of your female and African Americans, and so on.
Racist.
And none of the codes.
Cody, you get your graphic.
So, some of the next types of pre-processing that we want to talk about, and again, we're going to dive into these issues in more depth as we proceed through the entire course. So we're still kind of going down into everything. But dimensionality reduction, who remembers what dimensionality is defined as?
I've never heard of it.
It's dimensionality is the number of features, the number of characteristics, right?
Okay.
That you're looking, the number of attributes. Am I looking at weight, height,
Or the
Gender.
dimensions or something.
those would be your attributes. And how many of those you're considering is called the dimensionality.
Okay.
And so, another thing we can do to simplify our data sets is to reduce our dimensionality. It's called it's called the curse of dimensionality, that things get really big and really processor intensive as we, and the other issue is that if we have too many dimensions, sometimes you just end up with a lot of zeros because you're being too specific. So some things we want to do is we want to reduce the dimensionality. Some tools that we have here, I've listed a couple. These both come from linear algebra, principal components analysis. So trying to identify what are kind of the more relevant features for the problem, the principal components. And then singular value decomposition. Feature subset selection. You see redundant features. You don't need it multiple times if they're really getting at the same concept, the same type of measurement, but you're not necessarily seeing that. Remove irrelevant features. Again, you have to be careful. Who's deeming that they're irrelevant without going through and finding out? This last one, feature creation, sounds like you're actually increasing the complexity. Anybody have an idea of how that could simplify it? Jeremiah?
Maybe if you're summing up other attributes into one.
So maybe you can combine groups of attributes and say, really this is a group that I want to include as a single feature instead of all these other separate ones.
So,
Yeah, Nick.
so like I guess an example would be like if you have a group of ages from like 20 to 25 and 25 to 30, you're just grouping that as 20s.
Right,
Okay.
right.
Makes
I mean, that's a perfect example, that's the binning idea, but, instead of going 20, 21, 22, 23 ages, each one, are you 20, are you 21? Although age would probably be your attribute there, so that would be a little tricky.
So for feature creation and summing up like multiple attributes, it'd be more like when we were discussing the weather and whether we should go out and play.
Right?
Is it sunny, temperature, wind speed and all that stuff? You could just sum that up as a good day versus a bad day.
You could do that, or another option, I mean, you've heard of, they changed the name of it, but, instead of temperature and humidity, you get, and wind, you get the wind chill. Instead of temperature and wind, you can combine temperature and wind as your wind chill measure.
That is, okay, that's pretty.
So now you've reduced it by one, right? Okay, so I'm actually going to stop here because
Not this cloud's but not.
So let's jump into the
okay, so a couple of things I did. So one thing I want to mention is that I put,
Put us on camera.
That's okay.
I don't see them.
Well, I know, but I wanna see. it.
If
Because
their
there's
camera and their
videos.
mic's turned off.
Right, I'm gonna turn those on.
You just turn. No, you
No,
turn.
you
the
give them
option.
access.
Yeah, they-
So on the DataMind website,
That's a cool door.
so I'm gonna change the due date for the first homework assignment. It's going to be Wednesday,
Like this.
and I've put the assignment on the web,
Oh, sweet.
on the DataMind website,
So if you did the homework, you're a nerd.
and it is
We're all days, you can't see.
under homework, tasks, and deadlines. So there's assignment 1, due date, next Wednesday,
Is that page 16, 1, 2, and 3?
1, 2, and 3. And, if you don't have the assignment, you can click on the assignment and it'll bring up the problems.
How are the problems? I haven't looked at them.
Yeah, I
just thought it would work. Pretty, like, baby stuff. I ordered it, it's getting warmed up.